Can you all see my screen?
Can't see the screen, man.
Can you all see my screen?
Yes.
Yes, we can see you.
Okay.
Yes. I got man.
So I'm going to the slideshow. The internet is quite unstable. Some instability. So someone started sharing a screen.
It's me, Mr. Falabomi. I was just trying to test on whether my screen will be up when I'm on.
Yeah. Can you see my screen now?
No.
No.
It's just rolling. It's about to run.
I think it's network.
We cannot see your screen, man.
We cannot see your screen, man. Its network is rolling.
Okay, let me stop it and start again. Yeah. Okay. But you can't even see my face. I can't see my face either. Can you see me now?
Yes, ma.
Okay. I want to share from here. Okay, you can share from your end now, right?
Yes, ma'am.
Okay, so we should just go with you then.
Yes. Now, good afternoon, everyone.
Good afternoon.
My name is Mr. Babalola from Okotasi School. So I'll be talking on Introduction to Rockets and Satellites. This topic is what our SS3 students are having for this term. That is the fifth week topic. So I believe it will serve as motivation for physics teachers. So what are rockets and satellites? You say rockets and satellites are the bedrock of modern space exploration and communication. So from launching payload into orbit or providing what global connectivity. So this technology has revolutionized our understanding and utilization of the final frontier. So before we move on, let's talk about the learning objectives. So the first is to understand the evolution of rocket technology and its key milestone. 2, to explore the fundamental principle of rocket propulsion system. 3, to classify the different types of satellites and their unique orbits. Then the lastly is to examine the capabilities and uses of launch vehicles for satellite deployment. Now, firstly, what is rocket science? So rocket science is all about using rocket propulsion to move anything from a firework to a manned spaceship. And these rockets are the bedrock of modern space exploration and communication. So from launching payloads into orbit to providing global connectivity, so this technology has revolutionized our understanding and utilization of the final frontier. Now, what leads to the history of, let's go to the history of rocket development. The early experiments from the Chinese, it shows that the primitive rocket experiment dates back to the ancient times, with the Chinese using gunpowder-based rockets as early as the 13th century. Then the pioneer design, that is in the 20th century, before our century now, the visionaries like Robert Goddard pushed the boundaries, he and his colleagues pushed the boundaries of rocket technology with innovative designs, like what we can see on the screen. Then the modern advancements. Today, rockets utilize advanced propulsion system and materials, enabling larger payloads, greater efficiency, and more reliable launches. Now let's move to the fundamental principle of rocketry. That's the next slide. Now, from the Newton's third law of motion, according to Newton's third law of motion, which says to every action, there is always equal and opposite reaction. That is, for example, if you stand in front of a wall and push it hard, you will surely push backward. So rockets operate based on the principles of Newton's law, which govern the relationship between force, mass, and acceleration. And according to the Newton's law of universal gravitation, which says a body will be in a state of rest. Which says that is Newton's law of universal gravitation, which says that the force of attraction between masses is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. So that is where gravitation comes in. So we have it. So it shows the relationship between force, mass, and acceleration. So that's the fundamental principle of rocketry. So rocket engine generates thrust by expelling propellants at high velocities, creating the force necessary to overcome gravity and achieve lift off. Then the next principle is aerodynamics and stability. So as we have here, we can see from the diagram here, the big G, the capital G stands for the gravitational constant, and that is 6.67 times 10 to minus 11 Newton meter square per kilogram square. This constant. Then the small g stands for the acceleration due to gravity. That is 9.8 meter per second square, or approximately you can say 10 meter per second square. So the v, that is the velocity, and the t, time. So so the gravitation, velocity, acceleration, and time, they work hand in hand. That is aerodynamics and stability. So rocket design consider factors like airflow, because without gravitation, without gravity, air cannot flow. The airplane, the spaceship cannot flow. The air flights cannot flow without rocket. So rocket design considers factors like airflow, drag, and center of mass to ensure stable and controlled flights. Now, types of rockets and their application. Firstly, we have liquid propellant rockets, and that one is widely used for space exploration. So we said these rockets use a combination of liquid fuel and oxidizer for high thrust application, as we can see on the screen. That is liquid propellant rockets. So it uses liquid fuel and oxidizers to flow. Then we also have solid propellant rockets. So that one is simpler in design. So the solid fuel rockets are often used for military application. As we know, physics deals with lives. So the solid propellant rockets, it is simpler in design, and it uses what solid fuel. It is used for military application and has booster stages for launch vehicles. Then the last one, we have the hybrid rockets. So we have the liquid, we have solid, and we also have hybrid rockets. So the hybrid rocket, it combines both liquid and solid propellants. That is technology, that is physics for you. It combines both liquid and solid propellants. So the hybrid rocket offers increased safety and performance advantages, as we have on the screen. Then let's move to satellites. So then how does, before we move to satellites, how does rockets work? There are three basic requirements for a working rocket. Before get it moving. Hello. Hello, are you with me?
Yes, we are with you.
Thank you, ma'am. So we said in a rocket, the object being pushed is the end product of burning fuel, which shoots out of the back of the rocket as the fuel burns. So there are three basic requirements to a working rocket. The first is get it moving. Second is overcome the pull of gravity. And as we all know, the law of gravity, that is what? All what goes up must what surely comes down. So overcome the pull of gravity, and lastly, plot a course. So that is how, that is the basic requirement of a rocket. Now let's move to satellite.
Sorry, sir. You said something. Mute or mute. Mr. Babalola.
All right, I'm muted.
Okay, now there were three things you said. You said
yes, I said there are three basic requirements to a working rocket.
Okay.
The first is get it moving. Second requirement is overcome the pull of gravity. And as well as all of us, you know the law of gravity that says all what goes up must surely comes down. So if I overcome the pull of gravity, and lastly, plus the course, it will move into space immediately. So that's how to get a rocket moving. Then you now move to a satellite. Now, what is satellite? A satellite is a body which revolves around a planet. And we know the planet itself is a body that revolves around a fixed star. So as we know, we have 8 planets in the globe. That is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Pluto is no more is a planet. But here we are on the Earth planet. So the satellite here is the moon. And as you know, almost all the planets have one or more satellites. So these are called natural satellites. Now, from here, from what you have on the screen, we have the satellite orbit and strategies. So the first is low Earth orbits. Satellites in this orbit, on this orbit circle, that is, we are on the low Earth. So on this orbit circle, the satellites on this orbit circle the Earth at an altitude of 150. It is 1,500 to 2,000 kilometers, often used for Earth observation and communication. Then we have the geosynchronous orbits. So at an altitude of 37,786 kilometers, these satellites maintain a fixed position relative to the Earth's surface, and they are ideal for communication. So without the satellites, we can't communicate to each other as we are doing now. So it is because of this, through the satellites we can communicate now. You can see the effect of physics. So without physics, all these things we are doing, all this space work we are doing, all this space time you are doing, all this meeting you are doing online can't be possible without the use of physics. Then we have interplanetary tragedies. So you have the. Hello, are you with me?
Yes.
Yes.
I can hear.
Thank you, ma'am. So you have the interplanetary tragedies. So these ones, they are complex orbits. So the complex orbits on the space, they are required to send spacecraft to other planets. So utilizing gravity-assisted maneuvers. Now, can we go on?
Yes, we can move on.
According to Isaac Newton, it made us know that if we imagine a mountain high enough so that it rises above the Earth's atmosphere, so from the top of the mountain, we can fire a shell horizontally with some velocity. After some time, due to gravitational attraction, the bullet will fall on the ground due to law of gravity, according to Isaac Newton. Now, if the shell is fired with a greater velocity, it will move to another position. And that is how it will be revolving around the Earth in a circular orbit, as the moon does. So as we all know, that according to eclipse, moon and the Earth, they revolve around the sun. We have solar eclipse and the lunar eclipse. It is due to satellites that make us know that, and that is the work of space science. Now let's look at satellite communication and navigation. In satellite communication, as we know, that is the importance of satellites. Satellites enables global. Hello? Hello, can I go on?
You can move on, sir.
Thank you, ma. So satellite enables global voice, data, and video communication as we are doing now. That is the work of satellites. That's why we said physics is the foundation of science. Without physics, no science. So video communication is through satellites. They're connecting people and device worldwide. That is due to satellite communication. And we have the satellite navigation. So our GPS and other satellite-based navigation system provide accurate positioning and timing information for a wide range of applications. Then another importance of satellites is what? Weather monitoring. So satellites play a crucial role in global weather forecasts, tracking storm and monitoring climate pattern. The scientists will tell us that by this time next year, we can have solar eclipse or lunar eclipse. What makes them know that? That is the work of satellite communication. Now, there is nothing that have advantage that won't have challenges. As we know, in Nigeria, we are a developing country. So the challenges in rocket and satellite engineering, we have the shape here on the screen. So one is launch safety. One, we have to ensure that the safe and reliable launch of rockets is a critical challenge. As we know, it's a critical challenge because if you should launch a rocket in an unsafe way, it can cause disaster. So those are the challenges in rocket and in satellite engineering. So ensuring the safe and reliable launch of rockets is a critical challenge, and it requires meticulous design. Good testing and risk mitigation. Then second challenge is extreme environments. Rocket and satellite must withstand the extreme temperature and pressure and radiation encountered in space and during the launch. These are the challenges we face. Then the third is orbital debris. So the growing problem of space debris poses a significant risk to both active satellites and future space mission. But when we are teaching our students, the future scientists, that when we are teaching them this and we are telling them the future advancement, they too, because the children you are giving back to now, the students you are taking them, we are tutoring now, they are computer literates. So we must take them as that. So we should treat them as future scientists. So I'm sure by God's in the near future they will develop these challenges to be able to overcome it. Then the next is cost reduction. So lowering the cost of space access and satellite deployment is a key focus for the industry to expand its reach. That is financing. So the next slide is the future advancements in rocket and satellite technology. So the future advancements. Firstly, okay, before I go there, let me talk on velocity of an artificial satellite of Earth in a orbit. So where the gravitational attraction comes in. So we say for a body to move in a circle, the centripetal force should act on a body subjected to the what? Gravitational attraction. And that is where Newton's law comes in. And that is the formula. That is GMM. That is the M is the masses. You have two masses all over R. The R is the distance apart. So the M is the mass of the Earth, and the big M is the mass of the Earth, small m, mass of the satellite, and the R is the radius in which the satellites revolve around the Earth. So that is where we have the formula. That's F equals to GMM over R square. I believe scientists be able to deduce that. Now, let's move to the future advancement in rocket and satellites. The first is what? Reusable rockets. So reducing launch costs and environmental impact by developing rockets that can be launched, landed, and what? Reused. That's why I said we are giving back to computer literates. Their brain is as fast as computer. So, and they are future scientists. So they should work on this. We are giving them in the classroom. So we are giving them this in the classroom. They too, their brain is as fast as computer. So they will what? Eager to go further into research about the space rockets and satellites. So reusable rockets that can reduce launch cost and environmental impact by developing rockets that can be launched, landed, and reused. The second is what? Electric propulsion. So utilizing electric or a ion engine to power satellites, enabling greater efficiency and what? Longer mission duration. So these are what we are looking forward to by our students. What our students will come up in the near future. The great scientists, our past scientists, they have done a great work. So we as teachers too, we should be building up future scientists that will work on rockets and satellites. Then the next is miniaturization. So the rise of small satellites and CubeSats, which are more affordable and can be deployed in large constellation, should be encouraged in the classrooms. So we should encourage our students to develop small satellites and what? CubeSats. Then on orbit servicing. So developing the capability to repair, refuel, and upgrade satellites while in orbits, extending their operational. So these are what we are looking forward to. Thank you. So we have any question? So the question I want to ask, but before I go to the question, I may ask. So what can someone just, okay, if you have any question on what I've talked about, please come up with that before I go to discussion. And my co-physicist, that's our slogan, greatest physicists for the progress of mankind. Without physics, no technology. Physics is the bedrock of technology. So we are the greatest of mankind for the progress of mankind. So we still have discussion that my co-physicists can talk on. Thank you. So we are on question and discussion ground.
All right. Does anyone have questions? If you don't have any questions, we can just let Babalola complete the presentation. If you have questions, please.
If you have any question or any contribution to what I've said. Question or contributions.
Okay, in the absence of none, we can just round up so that the next
Okay.
subject will present
Now,
theirs.
So what, as teachers, we physics teachers, what we should go into the classroom to ask our students is, students, what are the most, after taking this topic, you should just sit them down. We create discussion method, we apply discussion method to our students and ask them, what are the most exciting future application of rocket and satellites? I believe students too, as I've said, that they are computer literate. So they too, they will have something to say. Then secondly is what? How can we address the challenges of space debris and sustainability in the space industry? So apart from what I've listed here, they will come up with their own ideas. Then the third is what? What advancement in proportion? And this also can serve as evaluation. It can serve as assignment for the students. All these questions, the questions I said here, so they can serve as evaluation for the students, and they too, they should come up with their ideas as great scientists. Thank you. God bless everybody. God bless Lagos State. God bless District 6. Thank you very much.
Yeah, you're welcome. Thank you. Fantastic presentation. You can now stop sharing your screen. And we'll take our group picture. Can everyone turn on your camera? Yeah, on this call now. Let's take a group picture. Which subject is next? Let me see. After physics, we have agric science. Yeah. Fantastic presentation from Crew Physics. We will see which subject crew is going to carry the day. And we are going to, we're going to take this to the district and they are really going to be celebrated. Crew Physics, thank you. So please put on your camera. Let's take our group picture.
No physics, no technology.
So that's a new slogan now. No physics, no technology.
Okay. So greatest physicist for the progress of mankind.
Greatest physicist for the progress of
mankind.
Okay, it's all right. Where is my face? Can you see me?
No, ma.
No,
I can't see my face. So okay. When did I turn on this video? I'm turning on my own video too. So you'll see me shortly.
Call that for Solat.
Yes, I am here.
You can see you, ma.
Thank you. Team Physics. We can only see how many people on the don't let your group see those basic technology. They were representing. Want to see your faces, oh.
It's because teachers are not many. That is people, students are afraid of science, they are afraid of physics. But now I believe with this space science, they will be eager to study physics more. That is why.
The thing is, over the time, our subjects, when students don't see beyond, it's just to study so that we will pass WAEC.
They
can't see the practical applications. They can't see, okay, how does this make me think innovatively? How does this make me solve?
Of space science, they too, and we during our own days. During our own days, we believe in theory, but students of today, they are computer literate. So their brain is very, so they are sharp. They think faster than during our own days.
Yes.
So we teachers too, I believe with this training, We too, we develop ourselves.
Sure.
Thank
Okay, so should I go on? I can't
Yes,
see just 1, 2, 3, 5. I mean, just 5. Okay, so when I say 3, 2, 1, smile. Please be clearer. Hold on to be clearer now. Okay.
Asola.
3, 2, 1, go. Let's take another one. I'll take one more.
For the progress of mankind. No physics, no technology.
Let me see. It's not, I want it to be very clear. So that your face. Okay, here we go. 3, 2, 1.
No way.
Got it.